Hello, welcome back to BlenderSushi Live Noding. In this episode, I'm gonna share with you this setup that I did using Sverchok add-on in Blender. It's basically based on an example by Sverchok developer. His name is KOSVOR, I think. He uses his node Scene Raycast MK2, which is kind of gathering all the objects in the scenes, like looking at all the mesh, and then um, through this setup, we can see that currently we have Suzanne head, and then it's actually animated using animation nodes. And this guy actually have like a real-time reflection, and this works really well for simple scenes. Although it can be unstable, I'm not sure maybe because of the this clashing between animation nodes and Sverchok. I'm not quite sure, but it with a simple scenes like this, like a low resolution Suzanne head, and then just this simple planes, we can get an interesting kind of a real-time ray casting happening. If you ever like try to understand raycast theory, this actually can help you to understand it a little bit better. So I'll build it from scratch. This is actually super simple. I'm actually quite amazed that this actually can work. So this is a Sverchok Raycast theory basic. I'm gonna switch to compositing, turn on Sverchok, and we have nothing in the scene. Okay, nothing. I'm gonna have maybe I'm not gonna use Suzanne head, but I'm gonna use a torus, simpler than Suzanne head. And then what I'll have is the bunch of points generated using Sverchok. I'm gonna use a plane and use the viewer draw, and by default the plane looks something like that. I'm gonna reduce the stepping, so it's basically I'm gonna reduce it until this square covering our torus, more or less. And I also want to center it out. Okay, so this is kind of the plan, and I'm gonna use 64 by 64 points, and okay, I think that's pretty good. Gonna turn off the points, and because we have 64 by 64 resolutions of pixels, we can use our texture viewer and use this extra small resolutions. This is to view our result of raycasting. So the idea is basically based on the position of those points. We're gonna like project the points until it's kind of touching our mesh, and we're gonna measure the distance between the original points and the way of until it touches the mesh, and then kind of generate like a real-time depth measuring. So I'm gonna create Scene Raycast node, and by default we have this origin. The origin can basically takes multiple points, which is gonna be our points from this plane nodes. The directions, we're gonna set it up just to shoot up in the z-axis. Shoot up or shoot down? I think it's shoot up, yeah, because it's the point is down there. It's gonna shoot up to our torus donuts, and based on that, we're gonna measure the length of the vector. We're gonna use vector math, and we have quite interesting function here. The one that we will need, we're gonna use is the length. This is gonna measure all the length of the ray being casted from the original points to the torus. I think that's how it works, more or less. So with the length being measured on the fly, we should basically being able to see a result. There we go. That's our tiny little donuts there. Currently it's very small. I think if I kind of make our, this is like a camera, like our square camera hole. If I make this a little bit smaller, we're gonna get a bigger donuts. Okay, this looks much better, right? Actually, we can do two things at the moment. Currently, it looks like just black and white, but it actually has like a grayscale kind of value. If we use math and maybe use multiplier 0.02, increase this slowly, we should start to see the depth of the donuts. Not so obvious. Maybe I should rotate the donuts. I'll make it, if I make the donuts under that plane, it's gonna clip. So that's kind of looking better, although we can't see the depth really clearly. So I decided, okay, let's increase the number of points here, 128 by 128, and then also change this viewer and make this even smaller. So we have like quite high res, 128 by 128 pixel, and we can see our object. Can't see too much of the depth, so I decided instead of using multiplier, I will use map range. So this value of the distance from the points to being the ray being casted into the object, I'm gonna make some tweak here. Hopefully we should start see some depth. I'm turning off the clamping, maybe that's why. Can't see too much of the depth still. Maybe I'll try Susan head. Put it over there. Okay, same thing. No, we don't see any kind of depth. I just noticed that I actually use this wrong parameter. This is the hit normal instead of the hit P. We need to use the hit P. And now hopefully we have the depth. You see there's a Susan head and there's a torus. They all kind of, we can see kind of depth. Okay, cool. Let's delete Susan head, just use the donut. We can have use we can use like a multiple donuts. Maybe even like use a twisted donut. Where's our extra object? Okay, twisted torus. Torus knot is actually interesting one to use. Okay, let's just use this object and put it on top of our camera and update Sverchok. There you go. That's our twisted torus knot being projected. It's not actually being projected. It's kind of like this is like a camera. It doesn't have any perspective. Probably it's just an orthographic camera that's kind of looking at the ray and measuring the ray. I don't know, like I'm not 100% sure about the theory, but I know the fact that it's casting a ray from just by experimenting. You can turn on and turn off the clamping, but I just turn it off. Okay, 128 pixel is kind of nice. It's a low res, but still, if you're thinking like pixel art, it's quite high res. 128 is pretty good. Imagine just like old school like video game. 120 by 128 is still kind of big. From this stage, I kind of thinking you could actually kind of set up like I say more or less like a filter. I think this kind of experiment is kind of related to OpenCV. OpenCV is like it stands for Open Computer Vision. So normally OpenCV works in real time, and you just use your webcam, and then through some just few programming script, because OpenCV also available as Python module, you can actually use a webcam, and then you use like a low res picture, and then in real time it can generate and process your image. So even though this setup is not like 100% real time, this is still pretty good. It's actually running at I check it, it's like 6 to 10 frames per second for low res image. You can actually animate this guy. See, I'm rotating the torus node. I can use animation nodes as well to do this if I want to animate it procedurally, but for now I'm just kind of rotating manually to show you the result. Anyway, saying all that, I'm gonna save this again, sorry, and then I'm gonna show you that we can actually randomize the input vertices. So our grid can be randomized, and as a result we should get like some kind of noise, kind of like more noisy kind of image. You see here, that's the result of the filter. So this almost like it's behaving more or less like a little bit like Blender compositor, or it's more like a Blender cycles and the way cycles work with all the raycast and then all those complex stuff. And with cycles, of course, you can have like a real-time render preview, and cycles really fast, right? And you see how the way it's kind of if you have like light in the scene and etc. Cycle is kind of doing that. See, it's rendering in real time, and the white with the setup that we have at the moment is kind of simulating that, even though it's still super basics, only like projected raycast, and then we are actually randomizing these points, randomizing the raycast actually, so we get this kind of blurry image. But still, I think it's kind of useful. I have not tested with other setup yet. Maybe okay. I like the noise, so I'm gonna keep the noise. And I'm gonna use fractal. Perhaps use these vertices. I'm gonna mix this together. Currently, our texture viewer is only capable of displaying black and white, no color yet. I'll try addition. So that's the fractal mixed with our noisy rays, but maybe multiplier. Oh, actually, multiplier gonna give you that effect. I just realized that that's not particularly interesting. But I think if I put the vector fractal back there, or if I'm using vector noise, maybe the result is gonna be more interesting. This guy plug into that guy, and this into this guy. What's the result? See, you see, suddenly you have like I'll create another node 3 here, so we can zoom in to that result. Yeah, suddenly you have this thing that's kind of distorting the torus node. I don't know how this happens, but it's kind of interesting, super interesting. In fact, if I change this to cell noise, for example, we get like a pixelated result. Not so interesting, but maybe 4 noise to crackle. a little bit better. I kind of like this standard Berlin result. It's kind of abstract. I don't know, I might render some thousands of this to test it out. But I believe it's distorting our image. Distorting it a little bit too much, but I can probably like reduce it using vector math here. Multiply by scalar 0.2, 0.5. Actually increase it. Actually increasing it, and you get even weirder result. Okay, maybe this is something that I have to try first, and then we perhaps in the next live loading I'll try more about this experiment. But anyway, the idea is really without all this noise and randomizations, we should get kind of like a reflection of our objects based on these points, and everything is generated in real time, and Sverchok is doing the hard job. And you can see the setup is super simple. This is really the basic of raycasting. Yeah, so hopefully this is useful. If you have any questions, suggestion, or any feedback, just let me know in the comments below. Thanks again for tuning in, and I'll see you in the next video.